Here's another quadratic equation that contains all three of the terms: the squared term, first power term, constant term. Our approach has typically been to solve this kind of quadratic equation using the quadratic formula. But we want to practice using the completing the square technique to solve a quadratic equation. So I'm going to use this equation to illustrate the use of that completing the square process. Remember, with completing the square, the coefficient of the squared term must be 1, which it is, which is why this is one that I would want to use completing the square. There are other equations I wouldn't want to apply completing the square because the coefficient of the squared term isn't 1. So when I have the coefficient of the squared term being 1, I can apply the completing the square process. We start by moving the constant to the other side of the equation, which I did by subtracting 19 from both sides. Now, we're looking to figure out what value can we add that will create a trinomial that factors into identical binomials. And the way we find that is we take half of the coefficient of the first power term and square that. Well, 1 divided by 1 is 1, and 1 squared is 1. So 1 is the number that will add to both sides of the equation. Make sure you remember to add it to this side of the equation. This trinomial then factors into these identical binomials. And the right side of my equation becomes negative 18 when I add those two terms. So this is the square of x minus 1. And now I can apply the square root property. Something squared equals a constant, and the coefficient on that something is 1. The something that's being squared here is the binomial x minus 1. So the binomial x minus 1 equals plus or minus the square root of negative 18. And that instantly tells me I'm into the imaginary numbers, and when I move the 1 to the other side, I actually have two complex number solutions. And we want to simplify that radical expression, the square root of negative 18. So let's see what we can do to simplify that expression. Well, the square root of negative 18, I could break apart into the square root of 9, because 9 is a perfect square number, times the square root of 2, times the square root of negative 1. 9 times 2 is 18. 18 times negative 1 is negative 18. Square root of 9 is 3. Square root of negative 1 we represent with I. So our solutions here are x equals 1 plus or minus 3 times the square root of 2 times I. We have these two complex number solutions. This is the real number part of the solution pair. This is the imaginary number part of the solution pair. And remember, we can't do any combining of the real number with the imaginary number. Those are as if they were unlike terms. They're unlike numbers, so we can't combine them. Those are our two solutions to this particular quadratic equation. I solved this one by using the completing the square method. And the reason it was nice to use this particular equation for completing the square is the coefficient of the squared term was 1. And that's a requirement for using completing the square.